Hello friends, myself Dr. M.K. Goku, Department Mathematics, Lorentz College Ajmer। हमारे पहले की लेक्चर में हमने स्पेशल थ्योरी ऑफ रिलेटिविटी के दो पोस्टुलेट्स के बारे में बताया था कि लॉज ऑफ फिजिक्स remains invariant in any inertial frames, and second one, the velocity of light is invariant in any inertial frame, and it is not dependent on the velocity of light, velocity of source or of the observer. Whether the source is in motion or observer is in motion, it doesn't matter. So, from these two postulates, we found that the Galilean transformations are not sufficient, not proper. They are not following these two postulates. So we need to improve these laws of transformations, and Lorentz came with these new laws of transformation. Lorentz transformations. Lorentz come with these some new transformations for following the postulates or holding the postulate. These transformations relate the observation of position and time. These transformations relate the observation of position and time. Means here we assume, in fact, these Lorentz transformations are known as special Lorentz transformation because we are taking a very special case. What is the speciality in it? That we have an inertial frame. This is known as y and z and x-axis. Statistically, I took the x-axis on the side, and this is one inertial frame, and the second inertial frame, which is attached with this, moving along with x-axis, means its y-axis, y-axis and z-axis moves parallel to this y-axis and z-axis, and this axis, this is the axis known as x-dash. So we have two inertial frames. Having origin at O and O dash. This second inertial frame, which is O dash, X dash, Y dash and Z dash, is moving along x-axis of the first inertial frame. Here we want to find the transformations related to position and time. So let us suppose this is a point or this is an event at point P, whose coordinate in first coordinate system is x, y, z and t. T is time, T is for time, and in second coordinate system its coordinates are x, y, x dash, y dash, z dash and t dash. These are the coordinates. where t dash is time measured by this clock. This observer, we suppose that there are two observers at place that O and O dash. दो ऑब्जर्वर हैं जो O और O dash पे प्लेस है. t is equal to 0 पर ये दोनों ऑब्जर्वर एक ही जगह है, इनकी क्लॉक एक जैसा टाइम बता रही है. दे आर सिंक्रोनाइज्ड. Their clocks are synchronized, and we assume in my previous lecture we assume that space, time, direction are equivalent. Space, time, and direction are equivalent, and this frame is moving with velocity v in this direction. Second frame is moving along with x-axis. The x dash axis is attached with the x-axis, and this second frame is moving along with the x-axis, and y dash axis and z dash axis are parallel to y and z axis respectively. Since the postulates the space are equivalent, we suppose that the space, time, and directions are equivalent. So, since the space positions are equivalent in all directions, therefore this x dash and x having a relation like this, x dash will be equal to alpha 1 x plus this since the space positions are equivalent, the space are equivalent, therefore x dash is, therefore all the transformation from one frame to other frame, transformation between these coordinates will be linear one. So I am writing here the linear equation between x dash and x and alpha 1 2 y plus alpha 1 3 z plus alpha 1 4 t. Similarly, y dash is equal to y and y dash is equal to alpha 2 1 x plus alpha 2 2 y plus alpha 2 3 z plus alpha 2 4 t. Similarly, z dash will be equal to alpha 3 1 x plus alpha 3 2 y plus alpha 3 3 z plus alpha 3 4 t, and t dash will be equal to alpha 4 1 x plus alpha 4 2 y plus alpha 4 3 z plus alpha 4 4 t. These are the relation between the same event, same point, relation between same coordinate of same point in first coordinate system, first inertial frame, and coordinate in second inertial frame having these relations. If we are able to find all these coefficients, since these coefficients are related, depends upon the relative velocity of this second frame with respect to first frame, that is on v. These coefficient depends upon v. Therefore, in order to find the exact transformation, we need to find these coefficients. Now, what happens in order to find these coefficients? What we have to do? हमें क्या करना चाहिए ताकि हमें ये coefficient मिल जाए? क्योंकि ये coefficient relative velocity v पे डिपेंड है और हमने साथ में ये स्पेशल ट्रांसफॉर्मेशन लिए हैं इस कारण से देखिए इसका y कोऑर्डिनेट क्योंकि y एक्सिस पैरेलल है तो y कोऑर्डिनेट वही होगा जो ये y डैश है. Means due to this speciality we have y dash is equal to y and z dash is equal to z. y dash is equal to y and z dash is equal to z. तो हमें क्या लाभ होगा इनसे, क्योंकि y dash और y बराबर है, इसका अर्थ क्या हुआ, ये कोएफिशिएंट y dash is equal to y and this is 1, this is 0, this is 0 and this is 0. So this y dash is equal to y. And again z dash is equal to z means this is 0, this coefficient is 0, this coefficient is 0 and this is 1 and this coefficient is 0. Now since y dash is there will not be any contribution of y and z, so this and this coefficient are again 0 and from here t dash, since y this is 0, this is 0, so we are left with these equations. X dash is equal to alpha 1 x plus alpha 1 4 t and y dash is equal to y and z dash is equal to z and t dash will be equal to alpha 4 1 x plus alpha 4 4 and t. Now in order to find the complete transformation, it remains to find alpha 1 1, alpha 1 4, alpha 4 1 and alpha 4 4. केवल हमें ये चार अब मालूम करने रह जाएंगे. अगर हमने ये स्पेशल ट्रांसफॉर्मेशन लिया है ना, उसका लाभ हमें मिलेगा. और लाभ क्या मिलेगा कि अब हमें इससे चार कोएफिशिएंट पता हो जाए तो हमारा काम हो जाएगा. यानी हम एग्जैक्ट ट्रांसफॉर्मेशन एक इनर्शियल फ्रेम से दूसरे इनर्शियल फ्रेम में जो कि रिलेटिव वेलोसिटी v से मूव कर रही है उसके कोऑर्डिनेट को, उसके इवेंट को हम एक दूसरे में ट्रांसफॉर्म करके बता सकते. तो अब ये चार मालूम करने हैं. क्या कहें, देखिए इनिशियली जब O और O डैश एक ही बिंदु पर हो, O बिंदु पर हो, तो क्या होगा, T is equal to 0. और उस केस में क्या होगा, T is equal to 0 हो जाएगा. उस केस में ये दोनों जो क्लॉक्स हैं, ये दोनों क्लॉक्स सिंक्रोनाइज हो गए. अब अगर ये x डैश मैं 0 कर दूं, x डैश 0, देखिए x डैश है क्या, दिस इज द डिस्टेंस, दिस इज द डिस्टेंस x डैश एंड व्हाट इज x, दिस इज द डिस्टेंस x. एक बार मैं x डैश इज इक्वल टू 0, x डैश अगर मैं 0 कर दूं तो क्या होगा, if x dash is equal to 0 then what will happen, this will be equal to 0 at time t is equal to t. Any event happens on that time will be the x dash is equal to 0 means this distance is 0, so position of O dash will be this one and this is nothing but x is equal to vt. This will be x, this will be x, x will be vt, x will be vt. So substituting here x dash is equal to 0, then 0 will be, with this equation gives us alpha 1 1 and vt plus alpha 1 4 and t. From here alpha 1 1 v plus alpha 1 4 into t will be equal to 0. Since at time t it happens at time t this point at this O dash is here, so t will not be equal to 0, so this factor will be equal to 0 and this gives us alpha 1 4 is equal to minus alpha 1 1 v. Using this equation, alpha 1 4 is equal to this one, I can write x dash is equal to alpha 1 1 x plus minus alpha 1 1 instead of alpha 1 4, I am writing alpha 1 1 v and t is 0. And y dash is equal to y, and y dash is equal to y, z dash is equal to z, and t dash is equal to alpha 1 4 x plus alpha 4 4 t. Now it remains to find only three coefficients. Which one? This I can write alpha 1 1 into x minus vt, and remaining equations remain same. So अब हमें केवल ये तीन कोएफिशिएंट मालूम है. इन तीन कोएफिशिएंट को मालूम करने के लिए हम वो जो हमने सोचा था स्पेशल थ्योरी ऑफ रिलेटिविटी के जो पॉस्टुलेट्स दिए थे, उसमें कहा था कि वेलोसिटी ऑफ लाइट इज कांस्टेंट, इट इज इंडिपेंडेंट ऑफ द वेलोसिटी ऑफ रिलेटिव वेलोसिटी ऑफ सोर्स और ऑफ द ऑब्जर्वर. सो हम ये मानते हैं एक वेव यहाँ से प्रोपोगेट करती है, तो चारों दिशाओं में सब तरफ बराबर दूरी तय करेगी इक्वल समय में. सी वेलोसिटी ऑफ लाइट इज कांस्टेंट, ये कहा था हमने. तो उसके आधार पर अगर मैं सोचूं तो क्या होगा, एक स्फीयर में ये जो प्रोपोगेट करेगी, इस वाले फ्रेम में भी वो स्फेरिकल वे में प्रोपोगेट करेगी और इस वाले में भी स्फेरिकल वे में प्रोपोगेट करेगी. तो उस स्फीयर का इक्वेशन दोनों फ्रेम में क्या होगा? फर्स्ट इनर्शियल फ्रेम में उस स्फीयर का इक्वेशन होगा x स्क्वायर प्लस y स्क्वायर प्लस z स्क्वायर इज इक्वल टू c स्क्वायर एंड t स्क्वायर. Expanding with time, this sphere is expanding with time with the velocity of c, so it is c square, radius is increasing continuously. And in second coordinate system, so velocity of light is constant in all the inertial frames, and it is independent of the velocity of source or of the observer. So here observer is moving, but according to second postulates, our velocity of light is constant. Therefore, here in second coordinate system will be x dash y square plus z dash square is equal to c square and t dash square. These are the equations of the sphere, and from the sphere of the wave propagated by the velocity of light or by c. So from these two equations, I can write x square plus y square plus z square minus c square t square will be equal to, since the velocity of light is constant, therefore I can write this is x dash square plus y dash square plus z dash square minus c square and t dash square. Now, since y is y dash, z is z dash, therefore we can write x square plus minus c square t square will be equal to x dash square minus c square and t dash square. Now, we can use these relations. X dash is equal to alpha 1 1 and x minus vt whole square. So this is whole square minus c square and t dash is equal to alpha 1 4 x plus alpha 4 4 t whole square. So c square and t dash square means square of this one. Now comparing the coefficient x square minus c square t square. Now comparing the coefficient of x square, I can write this x. Now comparing the coefficient of x square, xt, x square xt and c square. X square, xt and c square. What we can and t square. T square. What we will get? X square, here it is 1. On this side, this will give us x square. So, coefficient of x square will be alpha 1 whole square and x square. Here, c square alpha 1 4 whole square. Yeah, c square alpha 1 4 whole square. Then the coefficient of xt. Here, coefficient of xt is equal to 0. No coefficient of xt is here, but we have here two coefficient is equal to 0, means alpha 1 square, and squaring this we will get minus twice xtv. So minus twice v, and squaring this minus c square, and squaring this we will get twice of alpha 1 4 and alpha 4 4. So straightforward we can write this as c square alpha 1 4 and alpha 4 4, taking minus 2 outside, plus alpha 1 1 square and v, alpha 1 1 square and v. This is 0. And the coefficient of t square will be equal to minus c square, and coefficient of t square here alpha 1 1 square, and coefficient of v square will be t square will be equal to v square, and minus c, it is minus c square and alpha 4 4 square. So I can write c square is equal to c square is equal to this is c square and alpha 4 4, taking minus outside, whole square minus alpha alpha 1 1 square and v square. Is it correct or not? I can check it from the book that the derivations are correct. Let me check. Alpha 1 1 square, that is alpha 1 1 square minus c square alpha 1 4 square is equal to 1, and v alpha 1 1 square, v alpha 1 1 square plus, there must be some change. Let's take it. V, this one. V alpha 1 1 square plus c square. This one. V square. V alpha 1 1 square plus c square alpha 1 4 4 1 or 1 4 and this is 4 4, and last c square will be equal to c square alpha 4 4 square minus v square alpha 1 1 square. And using these three, we have this and this one. These three equations, we have these three, and we want to derive three values: alpha 1 1, alpha 1 4, alpha 1 4 or 4 1, alpha 1 4 and 4 1, and alpha 4 1. तीन वैल्यू मालूम करनी है और तीन इक्वेशंस हम इजीली मालूम कर सकते हैं. अब मैं इनको स्ट्रेट फॉरवर्ड लिख रहा हूं इन तीन इक्वेशन की हेल्प से. क्या आ रहा है? अल्फा 1 1, इन तीनों को सॉल्व करें तो हमारे पास आएगा E1 अपॉन अंडर रूट अल्फा 1 1 स्क्वायर है, यहाँ भी देखिए अल्फा 1 1 स्क्वायर है, यहाँ भी अल्फा 1 1 स्क्वायर है, तो स्क्वायर रूट लेंगे तो 1 माइनस बी स्क्वायर अपॉन सी स्क्वायर, where E1 is equal to plus minus 1, E1 is plus minus 1, alpha 4 is equal to E2 and under root 1 minus b square upon c square. Again E2 is plus minus 1 and alpha 41 or 1/4 will be equal to minus E2 v upon c square upon under root 1 minus v square upon c square. These are the E2 v upon c square. These are the E2 having the value plus minus 1. These are the values for alpha 1 1, alpha 4 and 4 1. So using these values of alpha 1 1, alpha 1 4 1 and alpha 4 4, we can write the transformation equation x dash is equal to x dash, it was alpha 1 1 minus x minus bt, I think so. X dash will be equal to this one. So alpha 1 1 is nothing but E1 x minus bt upon under root 1 minus b square upon c square, and when we will take plus 1 or minus t is equal to plus 1 or minus 1, we will discuss later on, that x dash is equal to this and y dash is equal to y and z dash is equal to z, and what is t dash? T dash is equal to alpha 4 1 and the combination of alpha 4 1 and 4 4, we will get t dash is equal to t minus x dash x v upon c square upon x minus upon 1 minus x v or vx, whatever it may be, we are saying. So t dash will be equal to t minus x v upon c square. These are the transformation of the event happening at point P from one coordinate system to another. Means यहाँ हमने x dash को इन टर्म्स में लिखा है, y dash को इन टर्म्स में लिखा है, z dash को इन टर्म्स में लिखा है और t dash को भी इन टर्म्स, इस फर्स्ट इनर्शियल फ्रेम के टर्म्स में लिखा है. यानी अगर हमें सेकंड कोऑर्डिनेट सिस्टम में इवेंट्स के पोजीशन वेक्टर चाहिए, मींस पोजीशन एंड टाइम वेक्टर चाहिए, तो हमें क्या आएगा, x dash is equal to this one, y dash is equal to y, z dash is equal to z, and t dash will be equal to t minus x v upon c square under root 1 minus v square. Well, v is the relative velocity of the second frame with respect to first frame. Now, if this second frame is moving in this direction, then we will take E1 and E2 as plus 1, and if we are using this as first frame and this is second frame, then this is lagging down, and therefore the second frame we can take E1 as minus 1 and E2 as minus 1, both. So these are the Lorentzian transformation equation from first inertial frame to second inertial frame of an event. If we want to write the reverse equations, means if we are known x dash, we are known the x dash, if we are known to these coordinates, मतलब हमें अगर इस पॉइंट पे ये कोऑर्डिनेट मालूम है, यानी सेकंड फ्रेम में ये जो ऑब्जर्वर सेकंड फ्रेम में बैठा है उसके ऑब्जर्वेशन हमें मालूम है, यानी x डैश y डैश z डैश और t डैश मालूम है, तो हम x y z को रिवर्स रूप में मालूम कर सकते हैं. और रिवर्स इक्वेशन क्या होंगे, x इज इक्वल टू x dash minus vt dash upon under root 1 minus v square upon c square. Y is equal to y dash and z is equal to z dash and t is equal to t dash minus x minus means plus हो जाएगा x. Instead of v, we have to use minus 3. Therefore, xv upon c square upon under root 1 minus v square upon c square. Means we are taking min x dash plus v. Instead of v, I am taking minus v. Here, this frame, second inertial frame is moving in this direction. Therefore, for the observer situated at this, will observe that this first frame is receding in this direction with negative velocity v. So we can use minus v instead of v. Here we can find the reverse equation. So in this way we can find the Lorentzian transformation from one coordinate system to another coordinate system. One more thing that is to be discussed today. A simple assessment of these transformations. Simple assessments क्या है? छोटे से इन्हीं ट्रांसफॉर्मेशन के दूसरे रूप Lorentz transformation equation can be put into the form C T dash will be equal to cos hyperbolic theta minus sin hyperbolic theta and minus sin hyperbolic theta and cos hyperbolic theta and to x and ct. यानी जो लॉरेंटियन ट्रांसफॉर्मेशन है उन लॉरेंटियन ट्रांसफॉर्मेशंस को हम इस फॉर्मेट में भी लिख सकते हैं. इस फॉर्मेट में भी लिखे जा सकते हैं वो लॉरेंटियन ट्रांसफॉर्मेशन. क्या है लॉरेंटियन ट्रांसफॉर्मेशन इक्वेशंस? हम अब यहाँ स्ट्रेट फॉरवर्ड लिख सकते हैं. x डैश इज इक्वल टू x माइनस vt अपॉन अंडर रूट 1 माइनस v स्क्वायर अपॉन c स्क्वायर. y dash is equal to y and z dash is equal to z and t dash is equal to t minus xv upon c square upon under root 1 minus v square upon 1 minus v square upon c square. ये लॉरेंटियन ट्रांसफॉर्मेशंस हैं जो हमने अभी भी देखे हैं, जो हमने डिराइव. अब यही लॉरेंटियन ट्रांसफॉर्मेशन इस फॉर्मेट में लिखे जा सकते हैं. इस फॉर्मेट में लिखे जा सकते हैं. इस तरह से हो सकता है ये. अगर हम एक ट्रांसफॉर्मेशन उन लॉरेंटियन ट्रांसफॉर्मेशन में अगर हम x वेलोसिटी ऑफ v कैन बी रिटन एज c tan hyperbolic theta. If we use relative velocity v as a c tan hyperbolic theta, then we will get 1 minus v square upon c square will be equal to 1 minus c square and c square cancel out. Then tan hyperbolic square theta, and this is nothing but sec hyperbolic theta and sec square hyperbolic theta, sec hyperbolic square theta, and in this way x dash will be equal to x minus x minus c tan hyperbolic theta at v. Instead of v, we took c tan hyperbolic theta and t. This is upon, this is under root of this is sec hyperbolic theta. So this can be written as x cos hyperbolic theta minus ct sin hyperbolic theta. This is for x dash and y dash is y and z dash is z. Now for t dash will be equal to t minus x into c cos c tan hyperbolic theta upon c square upon sec hyperbolic theta straightforward. So this I can write c, taking c is c, multiply this by c. So one c is cancelled out from here and multiplying by c, we will get ct, and this c is cancelled out. Therefore, ct dash will be equal to this one, and this I can write ct cos hyperbolic theta minus ct cos hyperbolic theta minus x sin hyperbolic theta. Sin hyperbolic theta. So x dash is this one and x ct dash is this one. Now x dash will be equal to cos square, we can use cos hyperbolic theta into x into minus sin hyperbolic theta into ct. This is the first equation. And c dash ct dash will be equal to minus x sin hyperbolic theta minus x sin hyperbolic theta and ct cos hyperbolic theta. This is ct cos hyperbolic theta. This is nothing but the combination of these two is written as this. So, special Lorentz transformation can also be written as this by using velocity of relative velocity of the second frame with respect to first is written as v is equal to c tan hyperbolic theta. Then we can write in this way. If this is written in iota imaginary form, means x dash is equal to x plus sin cos iota v. This cos iota theta. This is x as it is and x cos iota theta plus iota ct and sin iota theta. Means in imaginary form, this equation x dash can be written as x dash is equal to this one. Similarly, ct dash x dash can be written as this, and ct dash is equal to ct. So ict, this is cos iota theta. So ict, cos iota and cos iota theta plus minus x sin iota theta. Means rotation of an imaginary axis ct dash is equal to ict cos iota theta plus minus x sin iota theta. This transformation equation can also be written as this. Means a rotation of an imaginary axis by this angle iota theta, we will get these transformations. So Lorentz transformation, जो हमने ट्रांसफॉर्मेशन इक्वेशन निकाले स्पेशल लोरेंट्ज़ ट्रांसफॉर्मेशन कार्टेशियन कोऑर्डिनेट सिस्टम में, या जहां हमने उन पोस्टुलेट्स को स्पेशल थ्योरी ऑफ रिलेटिविटी के पोस्टुलेट्स को मानते हुए ये अज्यूम करते हुए कि डायरेक्शन इवेंट के जो डायरेक्शन है, इवेंट के जो पोजीशन है, इवेंट की जो वेलोसिटी ऑफ लाइट है, वो सब एक उन दोनों नियमों को फॉलो करती है। उनको मानते हुए जो स्पेशल थ्योरी ऑफ रिलेटिविटी के पोस्टुलेट्स हैं उनको मानते हुए अगर हम ट्रांसफॉर्मेशन निकालें तो ये ट्रांसफॉर्मेशन ये आएंगे। ये ट्रांसफॉर्मेशन लॉरेंजियन स्पेशल लॉरेंजियन ट्रांसफॉर्मेशन कहते हैं। और ईडी को इस फॉर्मेट में भी लिखा जा सकता है, इस फॉर्मेट में भी लिखा जा सकता है। वन मोर थिंग, अगर v, if v is very less than, if v is very less than c, then what happens? This factor will be 0 and we will get x dash is equal to x, this factor b square upon c square is very near about 0. I can say near about, tending to 0. So x dash will be x minus vt, y dash is equal to y and z dash is equal to z, and t dash will be equal to t minus xv upon c square, and these are nothing but the Galilean transformation. So if relative velocity of the frame is very less than the c, then naturally Lorentzian transformation will nothing but the Galilean transformation itself. So Lorentzian transformation always studied when the velocity, relative velocity is very higher, means one inertial frame is moving to other one with very higher velocity, then we need to use Lorentzian transformation. Next time we will see some more results about the Lorentzian transformation and composition of parallel velocities and etc. Other results also. Thank you very much.